Hello. So, second part of the updating information after the enhancement week boxer session. Just taking you through the force plate spreadsheet and explaining kind of what went wrong and how the force plate spreadsheet works. It comes down to some basic physics. The beginning of AS level physics, you learn what is known as the SUVAT equations because S stands for distance for whatever reason or displacement. U initial velocity, V final velocity, and then A and T acceleration and time. So I put that together, SUVAT. And there are a few equations which you kind of don't really know where they come from. They're essentially derived from substitutions. If you know that speed is distance over time, and you replace speed as distance over time, and then plug that into another equation, you end up replacing some terms with other terms, and you have a series of equations whereby if you do not know certain stuff but you know other stuff, then you can try and work out the unknown variables. So these are the SUVAT equations, and the one that is important is this: v squared equals u squared, so that's initial velocity, or in our case takeoff velocity when you jump in, plus 2as. And we know a, which is the acceleration due to gravity, which is always 9.81 meters per second squared on planet Earth. And then S is the distance, and that's kind of the height that we want to work out. Rearranging this equation and putting it into normal terms gives you the fact that height equals takeoff velocity squared divided by 2 times that acceleration due to gravity, 9.81. So another bit of basic physics is force equals mass times acceleration. Our way of expressing force is to say that if you've got a body with mass and it is accelerating or decelerating in a certain direction, then we will experience, or that body will experience, force. Now, taken together, these enable us to simply look at the force recorded by a force plate and know the duration, the sampling frequency, know how much time is going by, and then we can basically work out loads of other stuff. So first task is to get the vertical force from our force plate trace and then copy and paste it into this spreadsheet. So I've highlighted the columns here. We have column C and column I. These two columns are the vertical force in the z-axis. So we can sum this by simply going equals sum or equals something plus something, add those two things up, and then double click the bottom corner and it fills all the way down. As you can see, I've already done this. Then if you go insert and whack a graph in, we come up with this, which shows you the athlete standing, the athlete deloading, the athlete, concentrically contracting and then taken off where there is no force on the plate. So copy this force, because then that's the sum of the vertical force. Just so you know where that comes from, that is one plate, that is the other plate. We put 1 foot on either leg. Sorry, we put 1 foot on either plate, and then we've just simply summed those forces. Then, if we chuck that information into this column, so the FZ, the vertical force in the z-axis, we then have a force trace as shown by the same picture. So, to tell you where each of this comes from, force equals mass times acceleration. So the force on the force plate is going to be the force kicking back against the athlete's leg muscles when they are contracting to jump, but also there is the force that simply comes from their body weight, their body mass being pulled down by gravity at 9.81 meters per second squared. So to get the net force, that's what we describe as the total force that we see minus their body weight. So get that number there minus their weight, which is the standing weight, the force that we get on the force plate before they start moving. Then, because we know that acceleration is force divided by mass, because F equals ma, we just rearrange that. Then we get that net force and divide it by the mass, and we know that then we know how fast, how much the velocity is changing per second. We also know that we're sampling 1,000 times a second. So if we start with the assumption that we start at naught because they are completely at rest, then if we know that acceleration and then we times that by 1,000th, then we can basically add that onto the initial velocity of 0, add that onto the next velocity, add that onto the next velocity. So each change in force is therefore equivalent to an acceleration, which then means that we get a different kind of velocity as we sample each time in these 1,000 samples per second. So we see how that velocity changes, and then we can get an entire column just devoted to the person's velocity, and then we know their takeoff velocity. So we define takeoff as when there's less than 10 newtons of force on the force plate. So what this equation is this is a bit of Excel formula saying, please look for a bit where it drops down below 10 in this force column. And when it does, give us match. So give us the reference. How many rows down is it? So then we know that if we go 5,000 rows down, then we will find the cell which was basically the last cell before the athlete then completely takes off. So then if we cross-reference that, so if we go 5,735 cells down in this velocity column, then we will find the takeoff velocity. And that is what this formula has just done for me. Look up that number, go 5,735 rows down, and then that is your velocity. Square it, divide it by 2 times 9.81, and we have a takeoff velocity then turned into that S value, the distance. So we have managed to work out from takeoff velocity the height they have jumped. So yeah, I've gone and made some tweaks with the spreadsheet to make sure it all runs, but now you know where it comes from, so hopefully you can do what I've done, which is to be able to play around, although you might take a few days fewer to do it. But yes, I've gone and made some amendments, so hopefully this column now will be linked to here. So if you put in the sample frequency, the time in seconds knows to basically say, look, I'm doing 1,000th or 1/20th or 1/25th every sample. Net force, that's all done. All these are basic Suvat equations. Yeah, and the most important one is that it knows when they take off, which is when it's under 10 newtons. And then you look up that, you cross-reference using the match function to find out what the velocity is. Then we know takeoff velocity. Then we can work out height. I think job's a good one. I will save this. I will save this spreadsheet, and now hopefully, if it goes wrong, we will have that little bit more information to try and identify where that problem is. And yeah, got some of the basic math in there, where it comes from. So if you're bored, you can go through the spreadsheet. But yeah, there we go. We are looking at takeoff velocity rather than time in the air, because time in the air means that the athlete's technique and exactly making sure that they land in exactly the same position they take off, which isn't actually based in the real world. You're calculating your jump height based on an assumption that isn't true. People do not do not land in the same position as they took off, so therefore their time in the air actually gives an overestimation of their jump height. So yeah, we've done it via takeoff velocity. Right, if you've made it this far, you're obviously very, very bored. Cool. Right, I'm gonna